In this lesson, we'll be creating a Swarf Toolpath with contour selection. After completing this lesson, you'll be able to create a multi-axis Swarf Toolpath, modify toolpath parameters for multiple steps, and identify angle and overlap settings. Let's carry on with the file from our previous example, and let's talk about creating a multi-axis Swarf Toolpath by using contour selection. We're going to go into our multi-axis dropdown and select the Swarf Toolpath. The first thing that we need to do is select a tool. We're going to go into our Cloud Multi-Axis library, and we're going to use our tool number 6 3/8 flat end mill. From here in the Geometry section, we have Drive Mode set to Contours or Surfaces. We're going to get started by looking at Contours first. The selection mode can be Faces, Contour Pairs, or Manual. You'll notice that each of these has a tool tip that's displayed, and we're going to be using our Contour Pairs option. From here, we're going to select the upper contour that is leading into the upper fillet, and then the lower contour that is leading into the lower fillet. You'll note that we have some tool orientation and model options that we can use, but in this case, we're going to be using just these selections. Before I change any other settings, I'm going to select OK. Using the default settings, allow it to create our toolpath. Notice that instantly the orientation of the tool is wrong. It's upside down, and if we simulate this, we can see that the tool comes around. Not only is it working off the inside of the part, but it's also in the incorrect orientation for what we're trying to do. So we need to make some adjustments and some modifications. First, inside of our Geometry section, we have our contour pairs, and if we hover over this, notice that when we look at the selection mode, that the selected contours are going to be using the lower chain first. So this is an important distinction, and when we hover over this, you'll see that the preview shows the blue contour on the bottom and the yellow one on the top. So making sure you select them in the correct order is going to be an important key to ensuring that the toolpath is created properly. So now if we simulate this and play through, you can see that the tool comes down from the top, it rotates its way around, and cuts that contour for us by keeping the tool in contact with the upper and lower selections. It's important to note that this methodology is using the contours to keep those in contact with our tool and not the surface that's attached to either of those. So the surface could have some changes or imperfections in between those, but it's basing it solely on the contour selection. Let's go ahead and take a quick look at some of the properties that we have and can adjust in our passes section. First off, the cutting mode can be done single pass, and then we have a lot of other options here, from bottom, trim from bottom, from top to trim from top, spiral, and morph. Depending on the contours that are selected, in some instances, the contours might not actually be parallel. In our case, they are, but if they're not, we can use some of the other options to do multiple step downs, such as spiral or morph. We also have multiple passes. We can repeat finish passes. We can also add minimize axial motion. We can cut both ways. We have a long stock option that we can use. In this case, our stock is defined as the entire solid body, but if we want to drive it based on the stock, we can use that option. And then we also have, again, some overlap options, some sideways tilt options, and we have the options down here at the bottom for fan distance, segment length, and tool axis that are going to control parameters and how they get put into the NC file. We also have our traditional linking parameters, and again, I'm going to leave all these as default. We'll go ahead and have it recalculate this, and we'll simulate it one more time. Now that we have multiple passes, we're going to allow it to go through on the first pass, and then it'll lead into the second pass and create that final or finishing cut. So this is a great way that we can use the multi-axis swarf, assuming the machine that we're using is capable of this motion, to cut something like a tapered face without having to do a bunch of step downs with a rounded ball or bull end mill tool. From here, let's make sure that we save our file before we move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel. and don't forget to press on bell icon.